Well, my name is Steve Johnson. I'm with Orion Entrance Control. And Matt was so kind to volunteer me to come up here and introduce our next guest. And that's Tom Meckler. Tom comes to us from Bosch. I think you guys all know who Bosch is, but they do some pretty amazing things when it comes to motion detection technology, and that's what Tom specializes in. To that end, less of me and more of Tom. So take it away, Tom.
Thanks, Steve. Thank you very much. I was so excited when Steve asked me if I could do a detector technology presentation. So I'm the regional marketing manager for Bosch for all of our intrusion products. That includes all of our motion detectors, control panels, etc. And while I love our control panels, they usually get the limelight. You know, they're the exciting stuff. You got to program and all that. And you get to make them do all kinds of stuff. And they interact. People have to go to a keypad and press buttons. So usually people want to talk about control panels. But when Steve said, I want you to talk about detector technology, I'm like, dude, okay, this is awesome. Steve, the other Steve, I was thinking of Steve Pennington, asked me this morning, how long have you been involved with Bosch motion detectors? So I'm going to be 57 this year, and I've been involved with Bosch motion detectors for 50 years. So you wonder how that math works. So I'm in second grade. I'm walking down the hallway of number 42 school in Rochester, New York, and I look up, and in the corner is this box that looks like a camera with a little red light on it. And I look at it, and I wave to it, and the red light comes on. So I went to Mr. Zingaro. Mr. Zingaro was the vice principal at the time, and I said, Mr. Zingaro, I saw your camera in the hallway. And he said, yeah, and I saw you too. I got a little TV in my office, and anytime you're in the hallway, I can see you, so you better behave. Okay, so I always behaved. Not always, but I did in front of that thing. And every time I walked by, I'd wave my hand, right? And the light would come on. And I'd say, hi, Mr. Zingaro. Wind the clock 15 years later, I start with in tech support at Detection Systems, which is also, as fate would have it, outside of Rochester, New York. And I'm learning all the products. And here's the book of the old products if somebody has to call about one of these. So I'm going through the old catalog, and what do I see? This box. It wasn't a camera. It was an ultrasonic detector. If anybody remembers ultrasonics, it was a DS501 ultrasonic detector. Mr. Zingaro lied to me. All those years I thought I was waving to Mr. Zingaro, and he lied to me. It was actually a motion detector. So I've been involved with Bosch motion detectors for about 50 years. And it's a beautiful thing. What are we going to talk about today? We're going to talk a little bit about motion detectors and how they work. Actually, we're going to talk quite a bit about motion detectors and how they work, and the technology that goes behind them, because that sets the stage for explaining some of the testing we do in our Fairport facility to make sure we give you the best products. Then we're going to talk about some of that. We have a very high-tech testing facility and testing lab in Fairport. If you are interested in seeing how motion detectors really work and you want to take the drive up to Rochester, New York, don't come in January or February. You're welcome to, but I'm not recommending it. Please come up and see our lab. It's really an amazing thing. And when people come in, they say, motion detector is a motion detector. And when they leave, they say, I get it. And that's because they see our lab. So we're going to talk about that a little bit. And then we're going to talk about our motion detector line. A motion detector is a lot like a camera. And if we think about the different parts and pieces that are involved in the job that it does, that we can explain that. So there's important parts of the motion detector. One of them is the optics or the lens. And you think about a camera, and a good quality lens makes a big difference. One is the sensing element that gives us the ability to detect a person. And one, of course, is the signal processing. So all those things come together to make a motion detector. And I'll explain how all the parts are part of this whole thing here. If we look at how a motion detector sees the world, it sees it in little chunks, or little pieces. And I have this detector here is actually not an actual motion detector, but it has one of our lenses on it. And fate would have it, what it allows me to do is show you what the detector sees. So if I walk over here, you'll see these, sorry, I know I'm out of the camera. You'll see these lines. So that represents the energy that's coming back into the detector. And we talk about, can you see? So we talk about this as zones, where someone walks through the coverage pattern and their energy is reflected up into the detector in those zones, in those little parts and pieces. So that's cool because that does a lot of stuff for us. One thing it does is it allows us to determine what the coverage pattern is going to be. Most wall mount detectors, you mount them in the corner, you have a 90-degree coverage pattern, they cover the whole room, fantastic, right? That's what you want. But there's long-range detectors that have a narrow beam. There's ceiling mount detectors that might have a 360-degree coverage. So the lens system within the detector is how we create that coverage pattern so that we can catch the bad guy. So optics. Optics are important. They define the coverage area and the detection pattern. The sensor element is a little pyroelectric sensor. It's about as big as your pinky. And that's inside the detector. And that is a transducer. And what a transducer does, I like bringing up transducers because it brings me back to college, and I had a professor who just loved the word transducer. And he'd always say it like that, too, with a deuce. So the sensor element is a transducer. What a transducer does is it changes energy from one form to another. So this little sensor element takes the infrared energy that's reflected onto it and turns it into an electrical signal. So it transduces or transforms the energy, the infrared energy, into an electrical signal that we can process. So that's its job, right? So that's what it does. And almost all passive infrared detectors have a two-element sensor in them. And there's a positive and a negative element. And what that allows us to do is two things. I put up one finger. Two things. It allows us to detect motion because as someone moves through the coverage area, we get positive and negative signals. So you walk into a negative finger. Remember the fingers that were over there? You walk into a negative finger, and I get a negative signal. You walk into a positive finger, and I get a positive signal. So a series of positives and negatives gives me a signal that says, hey, something's moving. So that's one thing that the dual element detector does. And it creates a nice sine wave here, and I have some actual pictures of that as we go a little further into the slides. The other thing it does is it starts the building on fire. Now, Matt, this was not planned. What do? We are in the alarm business, so we should probably leave.
Thank you, everyone, for being compliant.
I say we go. What do you think? All right. Well, that was exciting. I promised these guys in the second row here I'd only use this joke one more time. Man, I was on fire, wasn't I? Sorry. Couldn't help it. That's the last time with all of you. So the two-element sensor, I said it helps us detect motion because we get these positive and negative signals. The other thing it does for us is it reduces false alarms by eliminating activations from the room changing temperature. So if the detector is looking at the wall is going to change temperature uniformly. Most things that aren't moving change temperature uniformly. So I get a positive and a negative at the same time, and they zero each other out. So that's why a passive infrared detector doesn't trip when the heat's on or the air conditioning's on, as long as it's not blowing directly at it. But when the room changes itself or objects within the room change temperature, as long as they do it uniformly and the detector's got both elements looking at that, there's no alarm because it zeroes it out, which is kind of cool. This chart shows us what happens and how important the optics are when we talk about how good the detection is. Remember when I shine this thing on the wall, and I'll do it again just because I can. And we see these multiple, looks pretty good right there. We see these multiple zones, right? These multiple fingers of detection. The more someone's in those, the more signal we get. So the more zones we get into, the more signal we get, so we get a much better detection. So what that allows us to do, and I have a slide later, is under most circumstances, a Bosch detector can catch a burglar in one step. Walk in the room, bam, we got you. Because of the way the optics work combined with our sensor element, combined with our processing. We'll talk about all that. But you can see these charts here, this green line, that's if someone is in all the fingers. Purple is all but one, orange, so on and so forth. So the more, when we're mounting our detectors, the more coverage that we expect the burglar to get into, the better we can do of catching them. So that's why mounting height is very important. We have some charts on that as we go further here. Now, we're gonna bring all this together as we move forward. I'm gonna say, remember that chart with all the sine waves on it? This is what you look like to a passive infrared detector. Remember, it's detecting the infrared energy that you're emitting. So you are an infrared energy emitter. You're giving off heat. And the detector can detect that. That's how it works. So it sees you as infrared energy that's moving through the room. And when you look at that person, you can see, wow, their head is pretty hot. Their torso's a little, pretty hot too. Their feet are pretty cold. So when we're setting up a detector, when we design the detector, and when you install the detector, you want to mount it so optimally it's detecting someone from their head to their waist, because that's where we're going to get the strongest signal. So when we say, hey, mount this thing at 7 to 9 feet, and you're going to get a coverage of 50 feet, that means that out at 50 feet, if you do everything we told you, it's going to be catching people from their head to their waist, and it's going to have optimal detection. Now, you mount it up higher, you mount it lower, you point the thing, and who knows what's going to happen, right? So this is what a person looks like to the detector. This guy's wearing a t-shirt. I happen to know that guy. It's not me. It's a former product manager. And you can see, wow, that's a really nice signal, right? So question for you. What if he puts on a hoodie? What do you think is going to happen? Anybody? It's going to degrade the signal. The signal is going to go down. So you can see that's the same guy with a hoodie, right? And we're getting signal here. But this one, man, that's beyond what we can measure. It's so strong. But this one goes up to that level. So it makes a difference, the amount of energy that you give off. So when that person's wearing a hoodie, it makes them harder to detect. But don't worry, we're still going to catch them. Because we have a feature in our products called dynamic temperature compensation. The burglar's temperature, we want to be different than the background. That's how a passive infrared detector works. The more different it is, the higher signal we get. So if their signal can be affected in a couple of ways. One is they're wearing a hoodie. The other is the temperature of the room rises to where it's close to body temperature. So even if you're wearing a t-shirt, you're walking through the room and it's 88 or 90 degrees in that room, the temperature is going to be very close to your outside body temperature. You're going to be a smaller signal that's harder to detect. But don't worry, because we have technology that helps thwart that problem. We have what's called dynamic temperature compensation. So we have a little thermistor inside the detector that's measuring the temperature of the room. And as the temperature of the room approaches body temperature, we increase our sensitivity. So remember how I showed you that one waveform was like this and the other one was like this? Well, for the first one, if we alarm about here, we're good. But that other one, the waveform's down here, and we're going to need to alarm down here in order to detect it. So we lower our threshold when the temperature gets close to body temperature. And then when it gets hotter, we move it back up. Because it isn't that it's hot in here, it's that it's close to a person's body temperature. So to the detector, 80 degrees and 100 degrees are the same thing. Because the optimal temperature is about 90 degrees. So 80 degrees and 100 degrees are about the same thing because they're a 10-degree change in temperature. So if it's 100 degrees in the room, we don't need to adjust the sensitivity anymore because it's a pretty big difference. So we go back to our normal sensitivity, which means that when it gets hotter and hotter and hotter, you're not opening yourself up to false alarms from other sources because your sensitivity is turned up. So here's where that mounting height makes the difference. Remember that waveform I showed where the person is in multiple zones of coverage? This is what the side of the coverage pattern looks like. So it looks like a bunch of fingers, right? And all these things in a Bosch detector are piled on top of each other in barriers or in stacks, right? So when you're walking through that coverage pattern and you're hitting multiple fingers, let's say just for the sake of argument, I need 50 points for an alarm, and each one of these is worth 25 points. Well, I got 75 points here, and I got 25, 50, 75, 100 points here, and so on and so forth. And those numbers are just arbitrary, but it gives you the idea that the more you can get the bad guy into the coverage pattern, the better you're going to detect. And this is that chart I showed earlier where it shows if I'm in 5 zones or 1 zone, the difference in the signal. That's why mounting the detector, mounting height, coverage pattern, all those things are important. The other thing that you may have noticed when I shine this thing on the wall is that some of these zones are more sensitive than others. The top zones in our coverage pattern are more sensitive because they're looking out high out into the room typically. And the ones that are looking down at the floor are a little less sensitive. Why do we do that, you ask? Why do we do that, Tom? Well, because there's things on the floor that can cause false alarms, rats and mice and dogs and cats and all those things that are moving around on the floor. So we need to compensate for that and still catch the bad guy. So the zones that are hitting the floor are less sensitive, especially in our detectors that have pet immunity. So our detectors, some of them, can ignore a 100-pound Rottweiler and catch a 90-pound burglar. And if you don't believe me, we got video to prove it. It's an amazing thing because of that technology. So here again is where you can see the mounting height makes a difference. So if the detector is mounted at the proper height, it's going to do a good job of detecting too high or too low, and you're not going to do a good job of detecting because you're either going to be looking at somebody's feet or you're going to be looking at their head. So if you think about this coverage pattern and I point it down, what do you think is going to happen? We're going to lose range out there. So I saw a detector mounted in a restaurant the other day. It was on a bracket and it was pointed down like that. Well, that was a 40-foot detector that was probably detecting about 20 feet because it's looking down at the floor instead of out like that. Oh yeah, that looks good over there. If we turn the lights out, it'd be really exciting, at least to me. So we talked about the sensor element and how that works and the type of signal that gives us. Signal processing is, it's a true story. I have been involved in motion detectors for 50 years, but I've really been involved for about 34 years, and Bosch has been in the motion detector business since 1968 when Detection Systems was founded in Fairport, New York. Somebody just mentioned he grew up over there and used to fish in our pond. Pond's still there. Fish too, except for the ones he took. So we have been processing signals from people for a very long time. So we know what people look like to a detector. So we have very sophisticated processing in our detectors. And what we can do is when you have good optics and you have good electronics and you get a very clean signal, just like a camera. Think about your cell phone camera from 10 years ago and your cell phone camera now. The optics, the camera itself give you such a better image. To a detector, a better image is a better signal. So that allows us to do a really good job of detecting it. And what it allows us to do is catch the bad guy in one step, but still ignore things that would cause most detectors to false alarm. Animals, giraffes, white light, those kinds of things. So we can, at the same time, these are rough drawings, but you can tell the difference between a person, an animal, a dog, and a space heater coming on, and we can detect those things. So based upon the timing, amplitude of the signal, how many signals we get, we can say, yeah, that's a person, gotcha. Or, I think that's a space heater, I'm not going to alarm. Another important part of motion detectors, so we've been talking about passive infrared detectors so far. Most of the detectors we sell are our Tritech detectors, which actually use passive infrared and microwave technology. So passive infrared detects a person's temperature, right? The change in temperature that occurs when an object moves in front of a background of a different temperature. That's the technical way to explain that. Microwave is more, it uses a Doppler shift. So it's more, it's not sound, but the best way to explain it is like sound, sonar from a bat, right? So if I'm a bat and I'm flying around, I'm sending out signals and they're bouncing off of objects around me. And by the sound that comes back to me, I can tell what's there. So I can eat the mosquitoes, right? If I was a bat, I don't eat mosquitoes personally. But that's basically how it works. You're sending out a signal, it's bouncing off in the room and being received. And as people move through the area, that signal that comes back changes. And the detector can detect, hey, if I see the signal doing this, that is a large object moving, and I'm going to alarm. We combine that with PIR, those two things together, and we get a detector that catches the bad guy in one step and ignores all other false alarm sources. It's pretty amazing stuff. One thing, when we talk about signal processing within our microwave, is a feature that we call microwave adaptive signal processing. And if we think about the microwave signal, remember I kind of equated it to sound. It's not exactly sound, but think of it that way. So you've got this signal, you're sending microwave energy out into the room and you're receiving the bounce back energy. And if other things that can cause that type of signal are present, you're going to get noise. Other things, I hear the air conditioner very slightly, but there's a motor in there, in those fans. The microwave is going to see that motor. The microwave is going to see we're getting out of fluorescent lights. Whoever thought that would happen? But fluorescent lights are starting to go away, but the gas inside fluorescent lights, microwave detectors can see that. So they see all this noise, and what happens is you have what's called a noise floor, right? So if you're fat, dumb, and happy, everything's cool, there isn't a fan going, and a forklift drives on the other side of that wall, it'll create a signal, but it's not enough to cause an alarm because it's below our threshold, right? But let's say you turn on a fan, you turn on a heater, you turn on the fluorescent lights, some other source of noise that the detector sees, and that noise floor rises up. Now that same signal, the forklift didn't get any bigger, but it could cross the alarm threshold, and now it would trip the microwave portion of the detector. Well, what do you do about that? You move the noise floor. You move the threshold that you're going to trip on an alarm. So a Bosch detector will ride, it's called noise riding. So a Bosch detector will actually take that signal and ride it along the noise. So we have consistent catch no matter what. So when you turn on the fan, the microwave will trip because it sees that noise. But then it says, hey, wait a second. This is a repetitive signal. It's going on and on. That's not a person. I'm going to ignore that part of the signal. I'm going to adjust my sensitivity so that I don't see that fan anymore. So it maintains that sensitivity. What that means is a couple things. We don't get false alarms because there's a forklift on the other side of the wall. And the detector has consistent coverage. So if the installer installs it when the fan is on, and they walk in the back of the room and it detects them, and you turn the fan off and it doesn't detect back there anymore, that would be a problem. So it rides up and down. So when the installer installs it, doesn't matter what noise is going on, when they leave, it's going to have consistent coverage no matter what. And that's a Bosch patent, by the way, that microwave adaptive processing. Okay. Fairport, New York. This guy, what's your name, sir? Red shirt guy? Michael. So Michael actually lived near the building that I'm going to show you some of the engineering equipment that's in there. So in Fairport, New York, we have probably the highest tech motion detector lab in the world. We think it is, and we know that because one of our competitors closed theirs. But we still, so if you ever want to see how a motion detector works, come to Fairport, New York, outside of Rochester, and we'll show you stuff like this. Radio frequency interference, or RFI, drives electronics nuts. So most electronics, if you pick them up, you see that little FCC label on them, that means that FCC has said, okay, you have some sort of microprocessor, you're emitting some sort of signal, but it's not enough to cause problems with other electronics, so they have to test that. Well, if you're a motion detector and there's all this wireless stuff going on, I'm on a wireless mic, you all have wireless phones, there's all kinds of wireless, there's Wi-Fi, there's all kinds of crazy stuff going on, that can have an effect on electronics, and if it has an effect on the electronics at just the wrong time, you get a false alarm. We all know about false alarms. It happened about 30 minutes ago based upon my little clock here. So we have to test for that. So we have to make sure that that type of energy won't cause a problem with our detectors. We have in Fairport what's called an anechoic chamber. Anechoic means no echo. And if I was in that room, I can hear my echo right now, but if I was in that room, it would be basically no sound. Real fun test, if you're ever in an anechoic chamber, pop a balloon. It doesn't sound like the big explosion you hear, it just goes phew, which is kind of cool. Cool demo, I used to do it all the time. You've probably figured out by now I'm a detector geek. But anyhow, inside this room, which is the anechoic chamber, of course it blocks sound, it also blocks electrical energy or radio frequency interference. So we can test inside that room, and we test multiple frequencies. We have this antenna here, and over here would be the detector. So we're zapping it with all kinds of different frequencies to make sure that A, it doesn't false alarm, B, it doesn't lock up. Because not locking up is good too, because you'd like to catch the bad guy. So we have to go through that range of testing. And on Bosch motion detectors, we picked the most stringent test in the world, and all of our detectors in the world meet that. So on motion detectors, the EN standard, which is a European standard, is actually more stringent than the US. So we use their standard when we make our detectors, and therefore we'll meet every standard everywhere else in the world, because if we meet that one, it's harder to meet than the other ones. So that's the anechoic chamber. This is some of the equipment that we use, so you can't really tell here, but there's a frequency generator here. It's automated, and it runs through a sweep of frequencies. We have some videos of this over in the other room, and this antenna will actually move, because as you may be aware, radio frequency energy, if you hit the right part of the wave, it has a difference in how much energy you get. So the wave's going like this, so we have to move up and down so the wave hits the detector at the right time, so we'll sweep through it like that and do all kinds of fun stuff. It's fun to watch. This is our walk test room, or our range room, okay? So in this room, this is where we actually walk test our detectors with real people and with fake people. I'll show you the fake person in a minute. But if you walk through the room, you see these blocks are about 2 meters, so that we know when we're walking, you have a consistent test of about 6 feet when you're walking through there. And we have all these different marks that are on the floor, and that's where we put our test fixtures. So we'll mount the detector to a machine like this, and we can raise and lower the height, and we can move it around the room so that it has a different view of the target, which is this guy right here, which is our robot. So we have a simulated person, a simulated target that we have, which is this robot. So this is the robot, and that's a person. So what's cool about this is we can change the temperature and control the temperature of different parts of the robot to make it look like a person. Remember, I said the head is really hot and the torso is a different temperature and the feet are really cold. Well, we have control systems that measure the difference between that target and the background, and they're different. So that's the head, that's the feet, that's the background. What's the difference between the target and the background? So we can do that, and that's happening all the time. What it does is it allows us to do a really consistent, accurate test of the whole system, the optics, the sensing element, the processing. So there it is. Now we can adjust the speed of that. It can go very slow, it can go very fast, depending upon the test we're doing. And a UL has a range of, hey, you have to detect someone who's walking like this, and you have to detect someone who's walking like this. And EN has different standards. So we test to the most stringent test standards there as well. And to make sure that it's accurate, repeatable, and consistent, we have our robot. And that is what the signal looks like to the detector itself. So this was on one of our professional series motion detectors, which has 2 PIRs and a microwave. So this is the upper PIR. This is the lower PIR. So you can see it hit that, actually hit the threshold. And then this is the microwave. So you can see there's my noise. Oh, and there's where somebody moved, right there in that part of the screen. So if you want to see this stuff in real life, I'd love to host you in Fairport and just work it out with Midchest. Bosch has a wide range of detectors and I'm not going to get to talk about all of the features, so I'm going to jump around a bit. One important feature for all of you, almost all of our current wall mount detectors are TAA compliant now. So if you visit Jenny Judah over at the GSA booth, she can tell you which products are on the GSA schedule. So 3 years ago, we didn't have a detector on the GSA schedule because all of our products were made in a country that didn't meet TAA. Now, almost all of our wall mount detectors meet TAA, and the other ones are coming. So I'm hoping that next year I have a few other detectors that I can talk about, ceiling mount, and that are TAA compliant. So we're getting there. We're working on it. COVID wreaked havoc on our plan, which was supposed to be done at the end of last year. But so we have all these detectors. We have the blue line detector. The blue line detector, this is the one that can ignore the 100-pound Rottweiler and catch the 90-pound burglar. But it's also meant for small commercial applications. So you can turn off that pet immunity and still have really good catch performance. So if you're doing a room, an office, it's maybe 40 feet or so, you're going to want to use that detector. Our commercial series, which is the next step up, this is our, I don't want to call it our standard commercial detector, but it's our standard commercial detector up to 50 by 50 feet. This is the one you're going to use for commercial applications, your warehouses, your armories, et cetera, et cetera. And it has a feature called cloak and camouflage technology. I don't have enough time to tell you exactly how that works, but that's how we catch the guy in the hoodie. So when that is turned on, we can actually adjust our signals. So if you expect somebody's going to be trying to come in here in a hoodie, turn on that technology and our signal is much tighter. We got the guy. And I can tell you that I have personally tried to get past these detectors with a hoodie, with a coat, with those kinds of things. If anybody can do it, it's me. I can't. So they're just foolproof. It ain't going to happen. And our professional series, which brings us up to we have a 100-foot curtain version of that, which you'll ask, well, how come you're not selling it right now? It's just about back on the market. For those of you that want to beat me up on that, you can hit me over at the table. But the standard detectors are 60 by 60 feet. The other feature these detectors have is anti-mask technology. Of course, we have ceiling mount detectors as well. The ceiling mount detector, that's coverage is a little different because it's looking down from the ceiling in a 360 degree pattern. We have outdoor detectors, and we have our request to exit detectors, and we are the leader in request to exit technology. A lot of you are protecting very high value, highly sensitive equipment, materials, and the people who might steal that or break into those areas can be very sophisticated. So they'll know that if the detector is looking at the wall and I block the detector, it ain't going to see me anymore. So we actually have technology called anti-mask technology in our commercial series and our professional series detectors that can detect someone blocking the detector. Put a box over it, put a baseball cap over it. The latest fun one is silicone sealant. They take silicone sealant and just brush it on the face of the detector and then come back later. We can detect all those things. We have multiple levels of anti-mask detector. And you should think about that if you think it's an application, especially where we expect an inside job or someone who might have access to that detector during the day for whatever reason. Think about anti-mask detection, because when you go to arm the system at night and that detector is in anti-mask, it'll say, not ready, I'm in anti-mask trouble. So you come and you find the silicone sealant and you'll wait for the bad guys to come and then you arrest them because they're the ones that did the silicone sealant. The other thing you need to know about Bosch, and if you think about Bosch in general, and the first thing that I hope comes to mind is reliability and robustness. And that's really what we hang our hat on. We do a lot of stuff. Our control panels, you can make them dance. I can make them dance. You can too. Our motion detectors are really, from a performance standpoint, the best in the world. When it comes right down to it, whether you have a Bosch tool or a spark plug or a windshield wiper or an intrusion product or a camera, it's robustness. It's going to last forever. The mean time between failures, which is a calculated number, but on our detectors is over 100 years. So if it hits 99, I ain't going to be here, so you can't hit me on it. But it's over 100 years. We expect that detector to just continue to run. And I mentioned that that PetImmune detector. I have one of the detectors from the first lot of the DS835i, which was one of our first family of PetImmune detectors I installed in my house in 1996. And I used to joke how it would catch my 2-year-old and ignore my cat. Well, it's on its third cat, and my 2-year-old's 23, and he's about this high. It still catches him in one step, and it still doesn't catch the cat. This stuff just lasts forever. It's reliable, it's robust, and it lasts for a long, long time. And it's TAA compliant on almost all of our wall mount detectors, and more are coming. Thank you very much.